everyone, welcome to the study of complex mathematics. We are looking at the integrals. So you are going to evaluate this. So the first thing is you identify the pole for cos of pi z over z minus 2 squared. Here we have the pole at z is equal to 2. A pole is a point where the function is not defined. This pole is of order 2 because of this power. And when you look at z modulus, which is equal to 2 modulus is equal to 2, this pole is inside our given circle, inside. So it is inside. Then, since it is inside, then we are going to get the residue for z is equal to 2. That is one of the residue. Also, from this one, the other pole is given at z is equal to 0 and it is of order 3 and it is inside also. So there are two cases. Case number 1, it is this for z is equal to 2. We get residue. R of 2 will be given by limit as z tends to 2 of first derivative with respect to z of our given function cos of divided by z minus 2. We square this z cubic, we multiply by z minus 2 squared, which is equal to limit as z tends to 2 first derivative of cos of pi over z cubic. So you are going to differentiate this function by what is called quotient rule. By quotient rule, whereby we are going to have a limit as z tends to 2 of negative z cubic multiplied by pi of sine of pi z plus or minus the denominator will be 3z squared cos of pi z, everything we divide by z power 6. So R2 is equal to limit as z tends to 2 of our function here, which is negative z cubic by sine of pi z minus 3z squared cos of pi z over z power 6. We can substitute the value of z to obtain the following: negative 8 pi sine of 2 pi minus 12 cos of 2 pi divided by 64 after substituting the value of 2. So R of 2 will be given by negative 12 over 64, which can be reduced to, you can divide this by 4, we get 3 over 64 divided by 4 is 16. So of integral of cos of pi z dz over z minus squared z cubic is equal to 2 pi I multiplied by negative 3 over 16 over 16 over 16, which is equal to negative 6 pi I over 16, which can be reduced to negative 3 over 8 pi I. This is the solution of this part for z is equal to 2. For z is equal to 2. So that's so much for doing the study with me. I leave you with the other part for z is equal to 0, and get the residue by taking the limit as z tends to 0. You get the second derivative of this function. Then you simplify and let me know you are working and the result which you are going to obtain after taking the derivative of this function and substituting it in the given equation. So do it and let me know the result which you are going to obtain after carrying out the derivative. Thanks so much for taking your time to study with me. Turn to my YouTube channel so that you don't miss a single video which I upload for us every day. Remember also to subscribe to the channel so that we may continue learning together. Also, you can make a comment in the comment section so that I may know any other approach which you could be having on how to tackle this kind of a question. I might see you in the next presentation.